Fundamentals of programming. Programming is the process of giving instructions to a computer so it can solve problems and perform specific tasks. In this presentation, we will learn the fundamental concepts that are common to almost every programming language. These concepts are more important than learning the syntax of a specific language, because programming languages are simply different tools for expressing the same fundamental ideas. What is programming? A computer program usually follows a simple idea: input, process, and output. First, the program receives information. This information can come from a user, a file, a sensor, a database, or another program. Next, the computer processes that information using rules, calculations, and logic. Finally, the program produces an output. The output could be text, an image, a sound, a file, or an action inside a video game. Understanding this input-process-output model is one of the easiest ways to understand how software works. Variables and data. Variables are containers used to store information while a program is running. For example, a program can store a person's name, age, score, or whether a particular condition is true. Different types of data represent different kinds of information. Strings are used for text. Numbers are used for mathematical values. Booleans represent two possible states: true or false. Understanding data is fundamental because almost every program needs to store, manipulate, and retrieve information. Operators and expressions. Operators allow us to manipulate and compare data. Arithmetic operators are used for mathematical calculations, such as addition, subtraction, multiplication, and division. Comparison operators allow us to determine relationships between values. For example, we can ask whether one number is greater than another. Logical operators allow us to combine multiple conditions. Together, operators allow a program to calculate values, compare information, and make decisions. Conditional logic allows a program to make decisions. The most common structure is an if statement. The program checks a condition and executes a specific block of code when that condition is true. An else block can provide an alternative when the condition is false. We can also use else if to check additional conditions. For example, a video game could check whether a player's health is 0. If it is, the game can trigger a game over state. Otherwise, the player can continue playing. Loops and repetition. Loops allow us to execute the same instructions multiple times. A for loop is useful when we want to process a known sequence or a specific number of elements. A while loop continues executing while a particular condition remains true. Loops are extremely important because they allow programmers to automate repetitive tasks. However, we must be careful with conditions. If a loop never becomes false, the program can create an infinite loop. Functions are a reusable block of code designed to perform a specific task. Functions can receive information through parameters and can return a result. For example, instead of writing the same calculations several times, we can create one function and call it whenever we need that calculation. Functions make programs easier to understand, maintain, test, and reuse. A good function should generally have a clear responsibility and a meaningful name. Arrays, lists, and collections. Programs frequently need to work with groups of related values. For example, a video game might need to store the player's inventory, a list of enemies, or the scores of several players. Collections allow us to store multiple values in an organized structure. We can then use loops to process each element. This combination of collections and loops is one of the most common patterns in programming. Algorithms and problem solving. Programming is not only about writing code. The most important skill is learning how to solve problems. An algorithm is a sequence of steps designed to solve a specific problem. First, we need to understand the problem and its requirements. Then, we break the problem into smaller and more manageable steps. After that, we implement the solution in code, test it, and improve it. Good programmers spend time thinking about the solution before writing large amounts of code. Debugging. Errors are a normal part of programming. Debugging is the process of finding the cause of a problem and fixing it. The first step is to understand the error message and identify where the problem occurred. Next, we try to reproduce the problem consistently. Then, we isolate the problematic part of the program and test possible solutions. Finally, we verify that the solution actually fixed the problem without creating new problems. Learning how to debug effectively is one of the most valuable skills a programmer can develop. Clean code and comments. Code is written for computers, but it is also read and maintained by humans. Clean code uses meaningful names, simple structures, and logical organization. For example, a variable called player health is much easier to understand than a variable called X. Comments can also be useful, especially when explaining why something is done. However, comments should not be used to explain code that is already obvious. The code itself should be as clear as possible. Object-oriented thinking. Object-oriented programming is a way of organizing software around objects. A class can be thought of as a blueprint. It defines what information an object has and what it can do. An object is a concrete instance created from that class. Methods are functions associated with an object and describe its behavior. For example, in a video game, we could have a player class with properties such as health and speed, and methods such as jump, attack, or move. The programmer's core mindset. Programming requires more than memorizing commands. Abstraction allows us to focus on important information while hiding unnecessary complexity. Modularity means breaking a large system into smaller components. Reusability helps us avoid solving the same problem repeatedly. Testing allows us to verify that our assumptions are correct. Finally, continuous learning is essential because technologies and programming languages constantly evolve. The fundamentals, however, remain useful across different technologies. The programming foundation. All of these concepts work together. We use variables to store data, operators to manipulate it, conditions to make decisions, loops to repeat operations, and functions to organize reusable logic. We use collections to manage groups of data, and algorithms to design solutions. We use debugging and testing to make our programs reliable, and clean code to make them easier to understand and maintain. The most important lesson is this: master the fundamentals first. Then the programming language becomes a tool for expressing your ideas.